Alright guys, today we're going to look at how we are going to be writing these verbal descriptions into our linear equations. So we've already been looking at how we could use a table to substitute that information and to graph from there. So let's go ahead and look and see how we're going to do this next part. Alright, so it says this first part is going to be kind of like our sentence stem in a way, so how we can translate. So translate means like if you're translating from English to Spanish, it's getting into the language that you know, or from Spanish to English or anything like that. So linear, remember, are going to be where we have a straight line. So we're going to graph those. We've been graphing them. And then we're going to write the equation. So we have y equals blank x minus or plus, and then we have another blank right there. So what we have are some key phrases for y'all. So when you have a verbal description, you know how we're going to write it. So if we had just this part, this is what we were used to when we said y over x, and that part went there. So dependent over independent, that's going to make our coefficient. So again, those key unit rate words were each, every, per, a, and. So for example, if you made $10 per hour, well, the dollars depend on the hours, so it's $10 for every 1 hour, so that would be 10 there. And that way you know, because you would multiply by the hours to get your total money, okay? So if you have each, every, per, a, and, those are your keywords, and that's going to go in front of that x. That's going to be your coefficient. And that will make sense once we look at some of these words, or problems, excuse me. Then, if you read or hear decreased by, less, or minus, we're going to circle that subtraction sign. If you hear the key phrase plus, and, more, also, in addition to, already has, increased by, then we're going to circle the plus sign. So just to remember, this number right here is called the coefficient. Coefficient. I think I spelled that wrong. Let me double check my spelling on that. Coefficient. Maybe my eyes are just started weird. Alright, and then this right here is going to be the constant. So the constant is the number just itself. Okay? Alright, so let's look and see what this is going to be. So it says a tennis club charges $30 per month. So as soon as I see per month and the number right in front, each, every, per, a, and, that 30 is going to go right there in front of my x. That means that the x is my months. Okay, so $30 times the months is going to give you how much you're paying total. So this would be my total dollars. The total money you spend depends on how many months go by. So $30 per month, and then it says plus $120 enrollment fee. So we have that keyword plus, so we're going to circle the plus sign. And the other reason we know that it's a constant, if you're paying something one time, it's just the number itself. So $30 per month plus the $120 enrollment fee. So these numbers right here is something that is only happening one time in the verbal description. Okay, so let's look at a couple more. Benjamin is saving money for a new laptop computer. He already has $50 as an account that his grandmother gave him for his birthday. Now he plans on saving $25 per week. Each, every, per, a, and. Each, every, per, a, and. Each, every, per, a, and. If you say that over and over and over again, it's going to help you to remember that that's what your coefficient is. So $25 per week, that means the 25 goes in front. And if it says 25 per week, that means that the x is actually the week. And what we're talking about is him saving money, so this is his money saved. And that makes sense. The total money saved depends on how many weeks go by that he's saving. Already has, well, is that going to be minus or plus? And we see already has right here pointing to the plus sign. So we're going to circle the plus sign. And again, if you think about it, that makes sense because if you already have $50, that's what you're starting with, and you're adding $25 every single week. So if 3 weeks went by, 25 times 3, well, that was $75 saved just in those 3 weeks. but we're going to add it to what he started with. So look for these key phrases. Use this sim to kind of help you out. All right, let's do 3 more. Nate needs to have his truck repaired. The parts he needs to have replaced cost $145. So right there, I don't see each, every, per, a, and. So I have a prediction that that 145 is going to be just the constant. Okay. The mechanic also charges $110 per hour. So again, I look for my unit rate word first, each, every, per, a, and. $110 per hour. So every hour that goes by, you're being charged $110, which is kind of a lot, but that's what the rate is, okay? Now let's talk about this $145. Well, those are the parts that he needs to get fixed on his truck. So you're going to do $110. Are we going to subtract that additional cost, or we're going to add it? Well, think about it. It doesn't have any of those key phrases in here, but if it's your total cost, we're going to add that. The only way that we would subtract this is if it was like a discount or a coupon or something like that. But these are the parts himself that he's paying a flat rate of $145 and then his hourly rate for the mechanic. All right, let's do 2 more. A pizzeria charges $6 for a medium cheese pizza plus $1.25 for each additional toppings. I'm going to go back over to kind of move it around. So in this situation, per hour, per week, per month, those were all right next to each other. But this is each topping if you think about it that way. So each is my key unit rate word right here. So it's $1.25 times how many toppings you want. And plus is my key phrase right there. So you're getting charged $6. So think about it. If you just want a cheese pizza, you're just going to pay $6. If you want 4 toppings on it, well, it's $1.25 times that 4, because each topping is $1.25 for each additional. So instead of saying 6 plus 1.25 plus 1.25 plus 1.25 plus 1.25, this is a faster way to write it. So this is the total price, depends on how many toppings you want. And this again makes sense too, because let's say you didn't want any toppings other than cheese. Well, $1.25 times 0 is 0, and 0 plus 6 is just 6. So that's your original price. Samantha is making bracelets to sell. She earns $22 per bracelet, each, every, per, a, and. So I already know that my X is the bracelets, and the 22 is my coefficient. So $22 per bracelet. So that's how much she's making. But she has to pay for the material. So we say less the $18 it cost her for the materials. So it cost her a total of $18 for all the bracelets she made. So are we going to add these or subtract? Well, if you're making a profit, you've got to pay for your product. Then you're going to sell it a little bit more than what you paid for to actually make money on that. So this is the money earned. So the money earned depends on how many bracelets she sells. But keyword is less, and we have that right there. So if for some reason we're going to say 22x minus 18. Okay, so this is the equation we would use to solve the problem. So that way we know how to write the equations so we are ready to solve them later on. All right, so this is what you're going to be using on today's lesson. Again, break it down, look for those keywords, each, every, per, a, and I like to kind of do that to help me out, to say that's going to be my coefficient. The number that's only happening one time is your constant. So in this situation, you're only paying $18 one time. This one, you're only paying $145 one time, and so on and so forth. Okay, so use this to help you understand today's lesson, and don't forget to reach out to your teacher if you need some help.